Hello everyone. Today in this lecture we are going to start about the new chapter Basic Mathematics. So in this particular chapter we are having different parts of it. So each and every topic we will be doing each and every lecture. So in that particular lecture we will be discussing about that topics. So firstly we are going to start with our first topic, that is our number system. So you will have a basic idea of what is number system and everything, because you would have already seen this number system from your 7th, 8th, 9th and 10th. You will be having this number system thing. So now it's like it can be a basic review of it, whatever we can say, it can be a very basic part of our mathematics. So now let's see our number system. So in this number system we'll start with our different types of numbers, right? So first we are having, that is natural numbers. So natural numbers are nothing but they are also called as the counting numbers. So the counting numbers 1, 2, 3, 4 and so on until some infinity are called the natural numbers. So for natural numbers we can call them as a natural, or else it can be called as a counting numbers, right? So the set of natural numbers are denoted by n. So these natural numbers, so for everything, for in mathematics it's nothing but representation without using our wordings, we just use our symbols, right? So here for natural numbers we will be denoting that set of natural numbers by capital N. So you can see here our capital N is nothing but our set of natural numbers which are nothing but starting from 1 and so on until infinity. So we can also represent our N as I dash or else Z dash, right? So these are our basic representations of our natural numbers. So the next we are having is whole numbers. So whole numbers is nothing but natural numbers including 0. So if you see in our natural numbers, we doesn't have 0 there. So when a 0 comes to the natural numbers, those particular numbers are called as whole numbers. So natural numbers including 0 are called whole numbers. So the set of whole numbers are denoted by capital W. So here our natural numbers has been denoted by N and whole numbers has been denoted by W, right? And the next type of numbers we are having is integers. So integers are nothing but both positive, negative numbers, right? So our positive numbers are nothing but, if you see in a number line, so here we will be having 0, 1, 2 and so on infinity. So the numbers behind 0 will be negative numbers which are -1, -2 and so on minus infinity. So these numbers including the minus infinity to plus infinity, only the numbers are called as integers, right? And this set of integers has been denoted by I or Z, right? You can see here we have taken one example of our integers. That is we have denoted our integers here, that is minus infinity to our plus infinity, all the numbers here, both positive and negative including 0. And the next here, if you see in the set of our integers, we will be having set of negative numbers. So we actually denote our integers by I or Z, and in that we will be having our negative numbers and positive numbers. So our set of negative integers is denoted by I dash, which is nothing but minus infinity to -1. And set of non-negative numbers is denoted by W, right? Non-negative numbers are nothing but our whole numbers. So they are nothing but whole numbers. Whole numbers will be denoted by W. And set of non-positive numbers are nothing but I dash, which is nothing but I dash plus 0, because non-positive in the sense 0 is neither positive nor negative. So 0 will be included here, right? So this is all about our integers. So the next type of numbers we are having, or in that integers we are having some classification, that is even integers and odd integers, right? So you would have known what is even numbers and odd numbers. So similarly here we are talking about our even integers and then odd integers. So even integers are nothing but the integers which are divisible by 2, right? The integers which are divisible by 2 are called as even integers. So integers in the sense we will be having both positive and negative. So the integers divisible by 2 are called as even integers. So here our example should be it will be like plus or minus 2, plus or minus 4 and so on. So similarly odd integers will be the numbers which are not divisible by 2, right? The numbers which are, or else we can say integers which are not divisible by 2 are called as odd integers. So we can take examples here. We can see here plus or minus 1, plus or minus 3 and so on, plus or minus 5, 7 and anything, right? So these are our basic classification: natural numbers, whole numbers, integers, even integers and odd integers. So now we'll get into our specific type of numbers. So the first one we are going to see here is prime numbers, right? So what is actually prime number? Which number is called as a prime number? So a natural number is said to be a prime number if it is exactly divisible by unity and itself only. So if you observe here, only natural numbers are said to be prime numbers, which means negative numbers will not be considered here. So a natural number is said to be a prime number if it is exactly divisible by 1 and itself, which means the numbers which will be having divisible by 1 and itself, those numbers are called prime numbers. So here you can see example, the divisibility for 2 will be 1 and 2. Similarly for 3, 1 and 3. We won't get 3 as a multiple of any other table, right? We won't get 3 as a multiple. So if you see any of this, they won't be getting they won't become as multiples in any other numbers except unity and itself, when they are multiplied with unity and itself. So these kind of numbers are called as prime numbers. So and the next we are having is composite numbers. So prime numbers is nothing but composite numbers is nothing but simply opposite to our prime numbers. So the numbers which are not prime are called as composite numbers, right? And the next we are having is co-prime numbers. So we have seen our prime numbers. So now we are having a further into it, that is our co-prime numbers. So when we take two natural numbers, those two said to be a co-prime if the HCF of those two numbers is 1, right? So you know how to find LCM and HCF. So if for example we are having two numbers which two natural numbers, so here also you have to understand that we are talking about only natural numbers. So two natural numbers, those who have HCF, the HCF of those two numbers is 1, then we can call those two numbers or co-prime numbers. So sometimes those two numbers are prime numbers itself, but not necessarily to be prime. So they can be composite too, but the HCF of both of them, that is the highest common factor, should be 1. So those numbers are called as relatively prime numbers, or else we can call them as co-prime numbers, right? And the next, again further in our prime numbers, we are having one more, that is our twin prime numbers, right? If the difference between two prime numbers is 2, then the numbers are called as twin prime numbers. So we know which all numbers are called as prime numbers. So if two prime numbers are having difference of 2, then those particular prime numbers are called as twin prime numbers. So you can see here example. So 2 and 3 are prime numbers, but the difference is 1. So these cannot be a twin prime numbers. And then we are having 3 and 5. So the difference between 3 and 5 is 2. So the pair of prime numbers 3 and 5 are called as twin prime numbers, right? So we have discussed our basic all and everything till prime numbers. So now let's get into our huge combination of numbers, that is our rational numbers and irrational numbers, right? So first see what is rational numbers, and then we'll get into our irrational numbers. So rational numbers are nothing but all the numbers that can be represented in the form of p by q, which is nothing but in the form of a fraction, where p and q are integers. So both p and q are nothing but integers, and the one more condition here is q should not be equal to 0. So these numbers are called as rational numbers, and their set of rational numbers has been denoted or represented by capital letter Q. So if you see examples for rational number, if I have written 2 by 1, it's a rational number. 1 by 2, it's a rational number. 5 by 7, it's a rational number. So the numbers which can be written or represented in the form of p by q, where p and q are integers, where our q not equal to 0, those particular numbers are called as rational numbers. So in the next type of numbers here we are having is irrational numbers, right? So there are real numbers which cannot be expressed in the form of p by q form. So irrational numbers are nothing but the numbers which cannot be, it's like quite opposite to our rational numbers. The numbers which cannot be expressed in the form of p by q, those numbers are called as irrational numbers, right? So these irrational numbers have been denoted by q power c, right? So if you see for this irrational numbers, we can take example of root 2, root 3, root 5, these and all nothing but our, even pi, these are nothing but our irrational numbers, examples of our irrational numbers. So if you try to find the decimal part of our irrational number, they end up getting non-terminating, non-recurring, right? So they, which means they neither terminate nor recurring. So the decimal part of irrational numbers will be non-terminating and non-recurring. If you talk in terms of rational numbers, in rational numbers we will be having two types of decimal expansion. One is terminating and the second one is non-terminating recurring, right? So if we talk about even decimals, these and all we will be having for both rational and irrational numbers. And the final classification we are having is real numbers and our complex numbers, right? So real numbers is nothing but the complete set of our all rational and irrational numbers. So the complete set of rational and irrational numbers is nothing but it's the set of our real numbers. So where we actually denote our real numbers by the capital letter R. So capital letter R is nothing but our real numbers. So where we will be having our combination of both rational and irrational numbers. So it's a set of union of rational and irrational number. And then another classification we are having is complex numbers. So a number which can be written in the form of a plus ib, right? So that particular number is called as a complex number. So where we can say in another way, the numbers which are not real are also called as our complex number. So these complex numbers are usually denoted by z, right? So here if you see a plus ib, so this is the basic format of a complex number. So I is nothing but it is actually root over minus 1, right? Where our a and b are nothing but they belongs to real numbers, right? So these are our total overall classification of our numbers which are there in our number system. And the next we are going to discuss is ratio and proportion. So first we will start with the ratio. If you are having two quantities a and b of the same kind, so they are of the same kind, then their ratio is nothing but a is to b, right? So ratio is nothing but a is to b, which we actually denote this by a fraction which is a by b. So a by b is equal to a is to b. This is nothing but ratio form and this is our fraction form. So a fraction is nothing but a ratio, right? So a ratio may be represented in a number of ways. Exactly. So a ratio can be represented in number of ways. For example, I am having here a by b. So this is the same, and if I multiply both by a number, this is also same, some ma by mb. So likewise we can represent a ratio in number of ways, right? And the next thing we are having is to compare two or more ratios, reduce them to their common denominator. So when we are trying to compare any two ratios, the first thing we should consider is the denominator should be common for those two ratios or any number of ratios which we are comparing. So these are our basic three conditions, we can say, basic introduction we can say for our ratio. And the next we are having is proportion. So when two ratios are equal, so we know what is a ratio, right? So let it be a by b, so this is a ratio, and c by d, this is also a ratio. When these two ratios are equal, when any two ratios are equal, then the four quantities composing them are said to be proportional, right? So a by b, for suppose a by b is equal to c by d. So this can be written as in terms of ratio a by b is a is to b is equal to c is to d. When they are equal, then we can say that these four quantities are proportional, which we can be represented as a is to b proportional to c is to d. So this is how we actually express when we have four quantities which are actually proportional, right? So here if you see, the a and d are called as our extremes and the b and c are called as means. So the interior ones are called as means and the exterior two are called as extremes. So an important property of proportion is nothing but product of extremes should be equal to product of means, which means here BC will be equal to AD. When we have four quantities which are proportional, our rule important property is nothing but product of means will be equal to product of extremes, right? And then here we are having invertendo and alternando. So here this is our two ratios which are equal. So we are actually inverting them, which means B is to A equal to D is to C. So A by B, the inversion of this will be B by A. So this property we called it as invertendo, and then we will be having alternando, which means we are altering, we are changing. So A by B is equal to C by D. I am interchanging, it's like A by C is equal to B by D. I am interchanging my B and C. So this property is called as alternando. And the next three here we are having for our proportion is componendo, dividendo, and both componendo and dividendo. So here when we say proportional, two ratios has to be equal. So A is to B is equal to C is to D. Then if you have, suppose if we have a condition like A plus B by B, for example A by B is equal to C by D. So sum of both numerator and denominator, that is A plus B by B in the numerator is equal to C plus D by D. So when we add our numerator and denominator and substitute that in the numerator, this operation is called as componendo. And we subtract it, that will be called as our dividendo. Right? When we add, that will be componendo, and we divide, when we subtract, it will be dividendo. So when means both componendo, dividendo means both addition and subtraction. So A plus B by A plus B by A minus B will be equal to C plus D by C minus D. So this is our componendo and dividendo, right? So these are our basic different types of numbers we are having in our number system, and then our ratio and proportion. So this is one of the part that will be included in our basic mathematics, and here in this particular chapter we are having few more lectures, so that will be covering in our next lectures. Thank you.